Yes, I am Kemal Selim Tekin Arslan, Android engineer in Holiday Pirates Group, and we have some markets with the different languages. We provide services with these 10 languages as a localization with the GraphQL. And today is our content. Let's talk about the importance of the efficient network communication, REST API overview, introduction of the GraphQL, challenges with REST, why we adopt the GraphQL, end of the day. Let's start with some questions. How many people only use the REST APIs? Only REST? Yeah, half of the room. How many people used or using maybe combine of the GraphQL? Yeah, 2, 3. Good. Maybe other part. This one. I never heard the GraphQL. Maybe afternoon I have a workshop. We can talk more coding part because you know that the limited time in presentation we just say technical part or some definitions. What is the REST and GraphQL? Yeah, let's begin the importance of the network communications. First, battery life is important for us, and maintain device battery by the minimizing data transmission, boosting the application's energy efficiency. Our more smart devices has no good battery now. You know, scalability is the second one. When network communication is optimized and application can handle larger number of the users, data requests improving its scalability and performance under increased load, and bandwidth optimization, streamlining communication, helping utilizing network bandwidth with a more efficiently, ensuring that the data transfers are efficient and minimizing of the consumption of the unnecessary resourcing. This is the important for us for the next slides. Yes, support for the low connectivity environment. We know that every city supports good connectivity, but underground or other limited connectivity part is as important for some companies or some users. And the last one, the improved user experience. We know that in the recent years, many statistics show that when screens in a app screens load slowly, users tend to uninstall our apps. And we check the Google Play statistics like fast load or slow rendering like that. Yes, second one is the REST API overview for us. REST and its key concept. First, REST is not too old. Representational state transfer represent an architectural style used in a design in a network applications coined by the Roy Fielding in his doctoral dissertation in 2000, and provides structured approach for building scalable and maintainable services for us. Uniform interface, this is the basic definition. We know that HTTP methods in REST part, this is like a predefined for us, and these URL correspond some methods. We know the traditional things, and when client send a request with specified URL, server handle it and return the JSON for us. These get, post, and put, delete methods, the classical predefined methods for us. Yes, stateless communication. REST operates in a stateless manner where every client request must carry all essential details for the server to proceed it. And the server does not retain any client-related information between the requests. Scalability and performance, it is important for our application scalability for the more users. And REST is a state-free and caching mechanism contribute to improve scalability and performance of the APIs, as a resource can be distributed and cached efficiently for us. And shortly, REST offers several advantages, emphasizing simplicity and adhering well-defined standards. REST ensures seamless compatibility, effortless scalability, efficient caching, and design for the optimal performance. Sounds good. And let's check the GraphQL part. The GraphQL fields the type categorize data into scalars representing atomic values like a string, the object representing the complex structure with the nested fields, enum types define the specific set of the values, and for the flexible data schema. In the GraphQL part, we have some schema. We will touch it next. And GraphQL start by the defining of our schema that describes the type of the data can be accessed and their relationships, serving as a contract between the client and server, outlining available queries and mutations. Yeah, we are using the Apollo GraphQL in Android and iOS part, and we will check the Apollo details for us because it is basically server SDK between our SQL server or data server and our clients. This is the example schema. We leverage Apollo GraphQL, its toolset fully analyze our schema and its fields. When you install the Apollo SDK detect all details like objects, scalars, interface in our data part, SQL part, whatever you have the SQL server. And this is my production, and automatically predefined our data results for us. And we can continue to its key concept. GraphQL has a queries. It is important for us because the data transferring data and filtering, sorting, some specifying desired fields like that. And we saw that we have a raw HTTP request basically, but the body has one query. Query say I need a user ID, normal name, something like that, and response just serve the required things. This is another example from the Apollo sandbox from my production GraphQL queries. This is the all fields definitions, and this allows us to flexibility run various queries in pre-development stage, providing critical insights into our data structure. Also, it is fit to multi-language support with single API, and we can first use the query, run the queries with some specified things, and then check the response before the development in front-end part. Yeah, this is the good example for us. Our client sent one request related with whatever it needs, like a post with related details, company, author. It is just one request, not in the rest. We need, that combined chaining response. First, we need a maybe set of ID list, and then chain second request with another results list of objects, list of post. But in GraphQL, we just define any combined things, and GraphQL SDK collects these desired properties for us and serve just related JSON for our response part. We have mutations like a CRUD items in the GraphQL, similar to queries, but this is modified data. They can perform actions like a create, update, and delete data. If we want, we can set some user roles also in our schema, manage who is an administrator, and send a delete request or modify request from the front-end part. Yes, challenge with REST. REST poses distinct challenges, and we tackle this by adapting GraphQL. Overfetching and underfetching. The data is important, and I will show something about the data calculation. Sometimes we use the internet like it is unlimited, but many devices or many people use the Wi-Fi to collect something or download something in App Store statistics also. And this overfetching and underfetching solve with the GraphQL. Specified data they need, eliminating both overfetching and underfetching issues. Client can specify shape and structure of the data and use this result directly. Multiple requests in REST API can require multiple endpoints to fetch various data type and define these multiple endpoint in REST part, like big classes. But GraphQL uses single endpoint for all queries, reducing number of API endpoints and simplifying API architecture and less backend effort to develop before the front-end or mobile team. N+1 query problem. In REST, obtaining related data typically involves multiple requests, causing the N+1 query problem, where one initial request triggers an additional request to retrieve associated data. But GraphQL part, the functions responsible to fetch in backend GraphQL SDK function responsible to fetch data for each field in design and requested in the query, allowing our development to efficiently batch and optimize data retrieval. And data loading, when we request something from the REST part, the endpoint retrieve full data set associated with that endpoint. But in the GraphQL part, client enable specified data, and when some part of the data is a fail, GraphQL serve the half of this data, like this part is a success, this service is a fail, and give some response, and we can draw half of the screen. Versioning, the REST, we know that we have some versioning, REST APIs, version 1, 2, 3, and so on. But GraphQL, we don't have any versioning. Robust type system and versionless schema facilitate smooth API evolution without risk breaking changes, allowing client request data in precise structure they need. Yes, this example, another example with GraphQL part. In REST part, we collect something, it will start again. Without GraphQL, our 3 API call and we get maybe put some data in the trash, but we need to fetch more data without GraphQL. Our API response, maybe our data class don't need, but network part completely get the JSON in the REST API, and we may match just 2 items. Yes, why we need to adapt? GraphQL was developed by the Facebook in 2012 and was open source 2015. It is fully tested and confident for the use live applications. It scales with the requirement even largest organizations, largely because of the powerful tooling and its compatibility with federated architecture. And these organizations use the GraphQL, but we know that maybe our structure, your company structure or project structure is not required day one. You just need to check like a new SDK. We need to test this SDK is ready to use or solve my problems like that. Front-end control over data, this is so important. My old experience, old companies, we always waiting to backend team because you know that the product team requests something, new feature, and backend team need a time. And in that time, we just mock something in the mobile or front-end part, and this mock or this development process recycle again and again. And in that case, GraphQL part, we just know the data in the database, and GraphQL SDK serve what I need in the mobile site, what I need the front-end website, the big screen or small screen like that. Real-time capabilities, also GraphQL support real-time updates through subscriptions, enable dynamic and interactive user experience for us. Federated architecture, we touch here. And versioning and evolution, GraphQL provides backward compatible approach to schema changes, enable smooth versioning, evolution of the API without breaking changes. Yeah, single endpoint, multiple source. This is the small iconography for the GraphQL client and sources. Single query retrieve multiple sources. This source part is our AWS or something like that, some data sources, and we install the GraphQL SDK between source and our clients, and clients request everything from this part. Also, parallel data loading is important on the GraphQL part. Performance and fetching related data concurrently. We touched at the multiple items, different items from the different sources in the one query, because we know that the user credentials or user details profiles is one data in a store, one our storage, another requested thing in another our data sources, and our SDK requests whatever we want. This is the resolver functions in GraphQL part. Fetch all things and serve the results. Yes, strongly typed schema. This clarify help developers understand query and API efficiently, reducing number of errors during the development, because we don't need to wait some API documentation from the other teams when we install the SDK and configure it in the backend part. Then we strongly type schema in the GraphQL Apollo SDK part. Elevating developer experience, efficient development workflow, self-documentation in API side, collaboration and front-end independence, and our current front-end team use the many items, but in the mobile side we just use the less items, and in that case we save something. Yeah, this is the small example. One data result, left-hand side, I just used the 3 item of the JSON results, but the next step, our backend team or front-end team requests new fields, gender, status, blah, blah, and these 5 items maybe is not much more data we first thought, because in mobile part we just say it is JSON result, okay, continue to parse, map, something like that, but I don't want to use in my UI part these new items, new fields. And our JSON result just 2 kilobytes increased after this implementation for my front end or my other teams. And then when we calculate the every not small companies, but middle companies has active users 1 million, and for my company I calculated the first month of this year, just 2 kilobytes per session. This is the REST API result, and when we calculate the a 5 times session for the one users, one device, and for the monthly, and 150 million sessions, total number of sessions, and in that case our network traffic over 300 gigabytes, just 2 kilobytes JSON increased response. And before this, before the GraphQLs, this is the so interesting results for us, and this is the who would like to shut down the one AWS server like that and saving something for us. And then thank you.